Welcome to September 17th LeetCode Challenge. Intersection of two arrays 2. Given two integers array nums1 and nums2, return an array of their intersections. Each element in the results must appear as many times as it is shown in both arrays. You may return the results in any order. So we're given nums1 here, which has array 1, 2, 2, 1, and nums array which has 2, 2. We want to return the intersection that has both the numbers that occurs in both of them. So that would be 2, 2 right here, which is in both nums array 1 and nums array 2. Similarly, in example 2, we have the nums array 1 here and nums array 2. We want to also return the intersection between these two. So which number do they have both in common? They have 4 and 9, right? Because this has 1 4, 1 9. This has a bunch of 4s, a bunch of 9s, but only one to make an intersection. Let's see. Numbers are between 1 to 0, 1 to 1,000, and the indexes are between 0 to 1,000. So this is a basic intersection problem. Here's some follow-up questions asking if it's already sorted, what do we do? How do you optimize it if it's sorted? If nums1 is smaller than nums2, which algorithm is better? If the elements of num2 are stored in disk memory, this is basically memory management. Alright, I'm gonna do, well, since it's giving us sorting, let's do a sorting type algorithm and find and this is kind of be more like basically a bigger explanation of the algorithm. So let's start off with let's sort them out to make it a little bit easier for ourselves. So nums1.sort, nums2.sort, and then next thing I'm going to do is I'm going to create a couple of things here. I'm going to use two pointers to kind of move along and check to see if the numbers are the same in both nums1 and nums2. So I'm going to call them pointer 1 and q for pointer 2. And then I'm also going to set that to be 0 and 0. I also need the output. Our output is actually going to be a list. So I'm just going to make a list right now. So we have two pointers there. We want to be able to move through them accordingly. So we need to be able to loop through it, nums1 and nums2, and I'll say pointer 1 is for nums1 and pointer q is for nums2. So while p pointer 1, well, the pointer for the nums of length of nums1, I should say, nums1, and q is less than the length of nums2. So we are going to do a couple things. We're going to do if nums1 at location p is equal to nums2 at location q. So the two pointers are the same, pointing to both indexes at this different indexes I should say, but the same number. Then you want to basically append that to our output because they both exist in both nums array. So we only need to put one of them. So let's say nums1 at p. Just need to add one of the numbers only. And then next thing we want to do is obviously we don't want to backtrack, so we just move forward. So we increment our p and q pointers. 1 and q is going to be incremented by 1. Okay, what if they don't exist? Else if let's say that nums1 at location at next pointer p, it's greater than nums at index pointer q. So what does that mean? It means that we have more numbers in one or the other. And if we have more numbers in nums array 1, no, more numbers in nums array 2, so therefore we need to move our q pointer ahead. So that'll be q incremented by 1. And also if it's greater, that means it's not the same number, so therefore we just have to move on anyways. And then lastly, else, or we don't need an else statement, but let's just do it for completion. Otherwise, that means that nums at nums at 1 at index p is less than nums 2 at index q. Therefore, we have to move our pointer p by 1. That means our nums2 array is larger, lengthwise is larger than our nums1. Okay, those are all good, and then we just cycle through this algorithm and then return our output. Alright, let's see if this works. Looks good. Awesome, submitted. So one good thing about this is that we cycle through the whole entire array at least once. So it's it's almost described as a single pass type algorithm. Time complexity is big O of minimum of p, minimum of either nums1, length of nums1, or length of nums2. So think about it this way. If we only have 3 elements here, we only need to find the smallest subset, or the intersection between these two. So if we cycle through 4, 9, and 5, and we find them all in nums2, that means that the big O time complexity has to be the size of the smallest one, because we're not going to cycle through the rest of it if it doesn't exist. So that should be the case for that, I believe. So space complexity is big O of n, because we store, or big O of minimum of O of n, because let's say that well, it's big O of a const, not of a variable, because for instance we have to find 2 numbers that exist in both, right? So it's big O of n, where n is is an intersection of either nums1 and nums2, so it's less than the longest, less than the shortest, I should say, equal or less than the shortest length of the nums array. All right, that is all. Have you guys a nice day. There's other ways of doing this too. I mean, other approaches, but I think this one works kind of this is the easiest thing I could think of. All right, have a good day, guys.